Good evening. Today's lesson is going to be about systems of equations and classifying them, whether they're what's called dependent versus independent, or what's called consistent versus inconsistent. Right down here, consistent, dependent, consistent, independent, and inconsistent. And we'll talk about these very in depth in just a second. The easiest way to visually see which they are is to graph them. So let's quickly graph these two equations. Y equals x minus 3, or the purple one. So I'm going to have a y-intercept of -3. It has a slope of 1. So I go up 1 and over 1. The green line has a y-intercept of 0 plus 0. So remember, there's no b values. That means 0. And it has a slope of 2, which means I go up 2 and over 1. Now, this is how we decide which it is. I first focus on the dependent versus the independent. If it's dependent, that means it's actually the same line, or the same equation. Nothing is different. But since these are definitely different lines, different slopes and everything, it's not dependent. So this system is not dependent. It's independent. The next thing we want to decide then, is it consistent or is it inconsistent? Now, consistent means the two lines will actually cross at some point. They cross, or they have an intersection. Inconsistent means they're parallel or they never cross. They're parallel. They never cross. Well, these two obviously cross. They crossed right here. So since they cross, that means they're consistent. They have a solution. Consistent means it has a solution. And if it's the same line, it has infinitely many solutions. So consistent means it has a solution or they cross. Inconsistent means they're parallel and they never touch. But if it's dependent, that means not only do they cross, they actually are the exact same line. So this one would happen to be the consistent, because it crosses and it's not the same line. Okay, so now as we move on, again, just very quickly, all you're going to do is quickly graph them and go, okay, this one has this green one, the top equation, has a y-intercept of -3, has a slope of 1/3. The purple line, or the bottom equation, has a y-intercept of -10, a slope of 1/3 as well, which means it's definitely not dependent, because that would mean it's the same line. It's independent. But it also has the exact same slope, thus means it never crosses. If it never crosses, it's inconsistent. So that would be inconsistent. And again, some of you will get very quickly at doing this without having to graph it, but it doesn't take that long to graph. Just hurry and do your y-intercept of 0, your slope of -5. This one has a y-intercept of 8, slope also of -5. But what we'll learn in the next lesson, we won't need to take the time to graph. I just look to see if the slopes are the same. If they're the same and it has the same y-intercept, in other words, if they're the exact same equation, it would be dependent and consistent. But since it has a different y-intercept, it's definitely inconsistent, or definitely independent, because it's not the same line, has a different y-intercept. And then since it has the same slope, or they're parallel, that means they're inconsistent. They never touch. So again, here we have a y-intercept of -4 and a slope of -1/2. The bottom one is just a horizontal line. Just remember, if you only see one variable, it's either horizontal or vertical. And if it's y equals, stay on the y-axis until you get to -1, and then don't go up or down, stay horizontal. And again, that's not the same line, so it's not dependent. And they do cross, so it's consistent, not inconsistent. Okay, again, different slopes. I definitely know it's going to be consistent and independent because it's different slopes. Unfortunately, you can't hit just submit. You actually have to graph them. But again, it's not hard. Down 1 over 6, crosses at 0 for on the blue one, and it has a slope of down 1 over 3. Now, if you'll notice, they do intersect. That means they're consistent, and it's independent because it's not the same line. If you have any questions on this, please bring them to class and I will help clarify.